first topic here is cations and anions. And so to understand these is that cations and anions both have at their root the word ion. And so for both of these are both types of ions, but they're different types of ions. Cations are positive ions, anions are negative ions. And so you can sort of, one way of looking at this might be to say, you've got the little T is like a plus sign right there. That's one way of remembering that cations are positive. Or you could know that the root an or a like that usually means not. And so anion would be like a negative ion, like a bad ion. Not necessarily bad, but you get the idea. So as we talked about in the last lesson, the previous unit, is that elements that tend to be on the left side of the periodic table tend to be positive charges, so those tend to be cations. Ones that tend to be towards the right side of the periodic table tend to form negative ions because they attract electrons because of their small size and such. So they're close to the nucleus, so they tend to be negative ions. Now, whenever we have cations and anions, in order to name them basically is, if we have one element, just one element that's become an ion, that it's considered to be a single or monatomic. So the root here is like like a monocle, means there's like a glasses thing that has only one lens. So mono is one, and so naming single ions, we're talking about single ions. The rules are different depending on whether it's a cation or an anion. If in a compound you have a cation, then the name of the ion basically is just the name of the element. So if I had something like sodium, Na, go ahead and take out your periodic table and take a look at sodium, you'll see that sodium on your list there says it has a charge of +1. And so that +1 tells you, number one, it's a cation, and number two, it tells you its charge is +1. So we've got that information there. Now for cations, the name in any compound is just the name of the element, so it would just be sodium in that case. If we looked at, say, strontium, strontium's a little bit lower, a little bit farther to the right, and you see it is +2. Also a cation, so if we were basically naming something, we'd say it's just strontium. Now, on the other hand, if we were to go to something like, say, chlorine, now chlorine's over on the right side, that means it's likely to be an anion, and sure enough, if you look at chlorine, it says +1, +5, +7, -1. The charge that's most common is going to be the -1, because it wants to gain one electron to get, it can gain one electron to get to a full set of valence electrons from 8. If it gained more than that, it wouldn't want to do that because they'd have to go up to the next energy level. So for chlorine being an anion, then the rule is basically this. So we have chlorine. To name a chlorine ion, basically what you do is you drop the last syllable, so "ine" drops out, and you're going to add to the end of it "ide." So the chlorine ion would be chloride in that case. That's what you do for anions. If we had something like, say, oxygen, we look at oxygen. Oxygen has a charge of -2, means it's an anion, and so in this case right here, instead of oxygen, we drop the GEN and add IDE for oxide. And so the ion of oxygen would be oxide in that case. And so that's how you go about naming cations and anions. Cations just take the name of the element, anions drop the ending and add IDE. Alright, so balancing ionic charges. Anytime that you have two ions, they combine to form a compound. Basically what they're doing here is that you have the one that is going to be a positive ion is going to give up its electron to the one that's going to be a negative ion. Effectively, if this is a covalent bonded element, or covalent bonded molecule, that would mean basically they share. The word here is co, and so they would share that electron. In other cases, you have what's called an ionic compound. In that case, basically the one that is more electronegative, that means wants to take the electron more, is going to steal the electron from the other ion and run off with it. And that's going to be the case of things that are usually salts tend to do that. But in general, is that if one element comes and takes another electron away from another element, the total number of electrons never changed. And so if it took one, that means it has a charge of -1, but the other one has to have a charge of +1. Those sets of charges have to balance out. And so what you'll find is in any element, or any compound, any molecule, is the total positives and total negative charges have to add up basically to be 0. And so the absolute value of both has to be the same. So if your negative charges add up to -6, your positive charges have to add up to +6. If your negative charges add up to -10, your positive charges have to add up to +10. And so overall you're going to end up with a neutral molecule. And so as it says, the ionic charges have to be balanced. So let's try this out with a few of them. We have sodium chloride, and so the first bit of doing this is going to be saying, okay, we have sodium. So looking for sodium on here that's Na. We have that right there. Chloride, the key part in looking at this is recognizing it has that IDE, and so we're looking for the element that starts chlor, and that's going to be chlorine. And so we look for chlorine, and chlorine is over there on the right side. And so chlorine, I'll make it a different color just so we can remember what we got here. Now to work this out, we've got to make sure that the ionic charges are balanced. So we look at sodium. Sodium has a charge of +1. And so we got +1 for sodium. Chlorine, on the other hand, says it is +1, +5, +7, -1. Now, if it were +1, +5, or +7, there's no way these could balance. You can't add up two positive numbers and end up with 0. You wouldn't have a neutral one. The chlorine has to be, in this case, the -1, and that sort of makes sense because, it's ins and ide. It has to be an anion. And so, by definition, it has to be the -1, and turns out chlorine's most common valence is going to be -1. So, in this case, NaCl, +1 plus -1, that equals 0. These are balanced. So our overall, we're already where we want to be. We've got the formula here. So we've got our total one, just NaCl. And that's it. Alright. So our next one, aluminum sulfide. So our cation here is going to be just aluminum. That one's pretty straightforward. Now the next one is sulfide. It does end in IDE, so that tells you that's an anion, as well as the fact that since aluminum is positive, it's going to have to be an anion. So we look up sulfur. Sulfur is +4, +6, -2. And so in this case it has to be -2. Whereas aluminum, if you look it up, is only one thing. It's only +3. And so we only have +3 for that. And so the question is, how do we get these to balance out? Because unlike the sodium chloride we saw before, 3 and 2 do not add up to be 0. And so to do this, what you want to do is you want to look for the least common multiple. And so what number it will both evenly divide 3 and 2. And so least common multiple between 3 and 2 is just going to be 6. And so how many aluminums do I need to have a total of +6 if each one is +3? I need 2 of them. Because 2 aluminums times the +3 gives me a total of +6. For the sulfurs, each one is -2. That means to get a total of -6, I have to have 3 of those. And so my overall formula for aluminum sulfide is Al2S3, like that. And so that's how you'd work that out. Alright, on to our next one, calcium bromide. First thing we look up is calcium. It is on the front because it says that normally is the rule, or always the rule is that cations are going to come front and then anions are on the back side of any written out formula. So we have calcium bromide. The first one here is calcium, Ca. If we look at the charge on calcium, it says it's +2. So +2 is the charge on calcium. The next one is bromide, ends in IDE, and so since it ends in IDE, that tells us it's the anion. And so bromide would be bromine. So we put bromine down here. Bromine is +1, +5, -1, but it has to be the negative. So -1. These numbers do not match up to start with, but we say what's the least common multiple between 1 and 2? What do they both go into evenly? Well, we'd have 1 calcium, and we would have to have 2 bromines. And so I have to have 2 bromines right like that. So our final one is going to be CaBr2, like that. Because 2 bromines, 2 times -1 is -2, plus +2 is 0. So that works out for that one. our last example here is carbon nitride. So for carbon nitride, the first one is carbon, and so we'll write out the cation as carbon. Carbon, if we look at it, is +2, +4, -4. So there are two possibilities. It could be +2 or it could be +4. Now, whenever you've got a case like this, is that for writing these out, is that technically is that this carbon, there should have been something to indicate what valence that carbon has. Probably it would be in between this. We'll talk about that in just a second. Since it's not here, what we're actually going to find is that the most common valence state for carbon would be 4, would be +4, because if you look at it, it's got 4 valence electrons. And so that means it could lose 4. If it only lost 2, that wouldn't be as common because it would have to, it would still have a couple in its valence shell, but it wouldn't have gotten rid of all of them. So this is going to be carbon 4, and so that's +4. Now the other piece here is nitride, and so nitride, drop the IDE, nitrogen, would be that. And of course, nitrogen is our other one that is most uncommon here. If you look at it, it's ±1, ±2, ±3, +4, +5. So this could be -1, -2, or -3 for its charge. Taking a look at nitrogen, though, you can see that it would have to gain how many electrons to get a full set of valence electrons, to get to 8. So it would have to gain 3 more. So nitrogen is one you just sort of have to remember. When it's negative, is almost always going to be -3. And so you just sort of have to remember that and memorize it. So unless you're told otherwise, nitrogen is going to have a charge of -3 when it's an anion. So we've got these two right here. We got 4 and 3. Least common multiple here is 12, and so 3 times 4 gives you that one right there. 4 times 3 gives you 12 right there. So those two would cancel, and so our final compound is C3N4 for carbon nitride.